Okay, so lesson 7.1 is looking at specifically rational expressions. So not just fractions with numbers, but then we're going to throw in a variable in there. Any rational expression can be defined as something that can be written as a fraction and that has a variable in it. But there are a couple of exceptions. Specifically, if you have a radical showing up somewhere, or if you have your variable in the exponent. In that case, these become different functions, this becoming exponential, and this one becoming a radical function, which we saw in our previous unit. Within fractions, we know that we're not allowed to divide by 0, which means that we end up with non-permissible values. What that means is that it's any variable that makes an expression undefined. In this particular case, that's the denominator is 0. Okay, so just for this first example, let's talk about our undefined values, our non-permissible values. Well, the denominator is not allowed to be 0. So we can say that x minus 3 cannot be 0. Now it's not going to be a greater than or less than thing because it's allowed to be negative, it's allowed to be positive. It's literally just not allowed to be that one value, 0. From here, we can manipulate it just like a regular equation. So x cannot be 3, and that would be my non-permissible value. Okay, so for example B, we've got our denominator cannot be 0. So 4sr squared cannot be 0. Now, unlike the previous example where we only had one variable in the denominator, now we've got 2. So when we have this set up, we use our 0 property. And we talked about this property originally way back in our second unit about quadratics. And we said that if things are multiplying to equal 0, then one of those things, one of those values has to be 0. So that means that either s would have not been able to be 0, and r squared cannot be 0. Now you could redefine that and say r cannot be 0 because if you take the square root of 0, it is 0. So these are my two non-permissible values in this scenario. I have to use that 0 property. And it shows up again in example C. So in this case, we look at the whole denominator, and we've got x times 2x minus 3 cannot be 0, which means that again we can break it into its pieces. X can't be 0, and 2x minus 3 cannot be 0. Now you might be able to spot it from all our work with quadratics, or you might have to do some arithmetic to manipulate that equation, but you're going to end up with x cannot be 3/2. So again, we've got two non-permissible values in this scenario. Finally, we end up in a scenario like D, where we're like, oh crap, well that's an actual quadratic expression. Don't panic, we already know how to do this, and we actually just did it in the previous question. It was just already factored for us. Whenever we're dealing with quadratics, it's essentially like talking about finding the zeros, but then saying those numbers aren't allowed. So the first thing we try and do when we're looking for the zeros of a quadratic expression or a quadratic function is we're going to look for factoring. This particular expression is nice in that it does factor well. And so p cannot be 4 or negative 3. And so that would be my answer for my non-permissible values. It's not an answer to a question because there is no question in this particular sense of like solving for your variable. I'm just simply stating my non-permissible values. Doing E, just to be sure. In this case, we've got x squared plus 1 cannot be 0. And so we can move that 1 over, we can try and factor it, but this is not a difference of squares. And so what we end up seeing is we've got x squared cannot be -1. Well, that's true. X squared will never be -1. And so then there are no non-permissible values. So when we talk about writing equivalent rational expressions, what we can do is we can multiply or divide by 1. Okay, it doesn't actually change the value of the fraction. It just kind of makes us need to consider what we're looking at. So we see that already when we were dealing with regular fractions. We could talk about 3/4, but that would be the same as 6/8. Well, really what that's doing is saying times 2 over 2. Well, 2 divided by 2, anything divided by itself, is equal to 1. So that is multiplying by 1. So that's what we mean. Whenever I talk about multiplying by 1, I'm talking about multiplying by a set of values, typically dividing, that are going to end up equaling out to be 1. We did actually adding 1, or adding 0 when we did completing the square, so it's in the same family. I haven't actually changed my fraction. It would reduce back down to 3/4, but it just gives us some different numbers to work with. So the first thing I always do is I write my non-permissible values. So in this case, I've got x squared plus x minus 10 cannot be 0. I'm going to factor that. So let's see what I can do. It's not factorable, so I actually would have to use my quadratic equation in order to be able to solve for this. So I'm going to go ahead and do that. So remember, x is equal to, or not equal to in this case, -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So when I plug in, I've got -1 plus or minus the square root of 1 squared minus 4 times 1 times -10, all divided by 2 times 1, which gives me a final answer of 41 under there. So -1 plus or minus the root of 41, all divided by 2. Those are my non-permissible values. So they're a little bit ugly, yes, but they still exist. We're allowed to take the square root of 41. That negative and negative becomes positive. So all of this works. So again, our strategies for dealing with quadratics is number 1, factor. Within factoring, always check first for greatest common factor if it's possible. Then our next step is if we can't factor and it's not going to be able to be rearranged to isolate our square, then we're going to have to use our quadratic equation. Now that I've defined my non-permissible values, though, I can go back and say, okay, well, if this is not factorable, then there's no way of like dividing out something out of both of these pieces, because I really don't know what I would divide out of that denominator. But I can multiply by 1, and you can literally choose anything. So if you chose 5 over 5, you would still be writing an equivalent rational expression. How that works? Well, we've got 5 times the numerator, 3x minus 6, and then 5 times the denominator, x squared plus x minus 10. We could then expand these, and we're going to get 15x minus 30 all over 5x squared plus 5x minus 50. And that would be my final answer. It's an equivalent rational expression. Now, it's not in its lowest form, so still not super crazy about it, but it is an equivalent expression, and that's just what we're introducing, that idea of equivalent expressions. Now, what we're going to run into here is we got to first figure out our non-permissible values. Always start with that. So we've got t squared minus 1 cannot be 0. Well, this is a difference of squares, which means it's going to factor out to be t minus 1, t plus 1. So always look for your special scenarios in addition to looking for greatest common factors. So t cannot be positive or negative 1. Now comes the interesting part. I could multiply this by 1, but I can also look for things that maybe I can take out of this expression. So I know my denominator can simplify to my factored form, t minus 1, t plus 1. Well, that kind of looks like the numerator, except the t is negative and the 1 is positive in comparison to this first binomial in my denominator. But what happens if I factor out a negative in my numerator? Well, it turns my t positive, it turns my 1 negative. And all of a sudden now I've got these two pieces that are exactly identical. What happens when you divide by two things that are exactly the same? Well, it's a 1, just like 2 divided by 2 is 1, 5 divided by 5 is 1. So if you need to rearrange it just so that you can wrap your head around that idea, we can talk about negative 1 over t plus 1 times t minus 1 over t minus 1. Now, you do not need to write this out. Okay, this is just me kind of explaining how this works. So I'm going to take these two pieces, I'm going to write them as a separate fraction and multiplying by whatever is left over. But because it's divided by itself, that is equal to 1. When you multiply by 1, it's itself. So my final answer is actually negative 1 and then t plus 1 in the denominator. But I still have two non-permissible values from my original expression. So I have to keep all my non-permissible values. Okay. We see the same sort of scenario happening in C. So that's why I always start with my non-permissible values, is because I can forget about some of the ones that I've canceled out otherwise. In this particular case, it's nice and simple. My denominator is x, so x cannot be 0. But again, I've got a scenario where, in this case, my numerator, I can take out an x. There's an x in common in both terms, which leaves me with 3x minus 8 over x, which simplifies to be 3x minus 8. And so my expression would be 3x minus 8, but x would still not be allowed to be 0. Trying D, again, whenever we can factor, we want to factor. Now, in this numerator, I can already spot that this is a difference of squares, but my variables at the back end, we don't usually like having that unless it happens to be set up that way in the denominator as well. So I'm going to rearrange it by taking out that negative again. So it's x squared minus 16, switch the signs of both those terms. And I'm also going to factor my denominator. Now I'm going to do that over here because once again, I want to figure out my non-permissible values before I start looking to cancel anything, if I can. So I've got non-permissible values, x squared minus 11x plus 12 cannot be 0. So that factors out to be negative. If we are multiplying to be 12 and adding to be 11, again, this is not factorable. Okay, and proof's kind of in the pudding. 12's factors need to be the same sign, so either both positive or both negative, to give us that positive 12. And my options are 1 and 12, which the difference would be 11, but I can't have a difference when they're the same sign. Or I can have 2 and 6. Well, that equals 8. And I can have 3 and 4, but that gives me 7. So no scenario gives me 11, which means again, I am dealing with my quadratic equation, negative b plus or minus the square root b squared minus 4ac, all divided by 2a. Negative 11. Okay, and again, watch those signs. That negative is attached to the 11. I've got positive 1, negative 11, and positive 12. That's A, B, and C. We've forgotten that. Plus or minus the square root of negative 11 squared minus 4 times 1 times 12. And we'll see how that shakes out in 2 times 1. We got 11 plus or minus the square root of 144. Nope. 121 minus 4 times 12 is going to be 48, all divided by 2. And so x cannot equal 11 plus or minus. If we use our mental calculators, that should get us 81 square root of 73 divided by 2. There's no way of breaking that radical down into simpler terms, so I'm going to leave it just as this. So again, I've got some ugly non-permissible values, but they are non-permissible values just the same. Because I cannot factor x squared minus 11x plus 12, unlike the previous two examples where I was able to factor out and divide by 1 essentially, in this case, I can't, which means I have to multiply in order to be able to write an equivalent fraction. So writing something like times 2 over 2 would be fine. What I'm actually going to do, though, is I'm going to do this. I'm going to x over x. How does this change things? Well, I'm introducing a new variable in the denominator. Which means I need to account for that in my non-permissible values. So x cannot be 0 either. Then I can multiply this through. So we've got negative x times x squared minus 16 over x times x squared minus 11x plus 12. Keep going. I should get negative x cubed plus 16x, all divided by x cubed minus 11x squared plus 12x. And I'm done. So technically this is equivalent to my original question. It looks even more complicated though. So again, usually we're going to be looking to divide by 1, not multiply by 1. That's good practice just the same. So do some textbook work. This is all of A4, and then you can write your assessment and you're going to be able to continue on to the next lesson.